Yes. Then we come to this question. It says, the rate versus time graph below is for the hypothetical equation given. Okay. The change at T1 is due to temperature change. The question says, state what happened at T1 and explain. You choose from temperature increase or temperature decrease. Okay. What happened at T1? The answer is temperature increase. Yeah, that is that. And why? Why do we say temperature increase? The reason is that at T1, what do we observe? Increase in the rate. Remember, this axis is rate. Increase in the rate. And the rate is increased when temperature increases. And that's the reason. Yeah, that is it. Yeah, then comes this question. It says, identify the nature of reaction and explain. Okay. Yes. You choose from endothermic or exothermic. How do you go about that? Okay, the best approach is to first have the equilibrium. It is x plus y giving you 2z plus p. Okay, and you need to know that at T1 temperature increased. Okay, and reverse is favored. So reverse favored means that this side is favored, and temperature increased means that this side is endothermic. Because you need to know that according to Le Chatelier, increase in temperature favors endothermic. So which means that reverse is endothermic. But you need to know that reactions are given in the form of forward. So if reverse is endothermic, it means that forward is exothermic. And our nature is given by the forward, so it means that enthalpy change will be less than 0, meaning exothermic. And that is it. So what is the answer? Exothermic. Yeah, that is it. And what's the reason? The reason is that rate increased and reverse is favored. Yeah, then comes this question. It says, what is the effect on Kc or equilibrium constant by the change at T1? To answer this question, you need to know that we have already identified that enthalpy change for this equilibrium is less than 0. Okay? And what happened at T1? Temperature increased. Now you need to know that for exothermic reaction, increase in temperature decreases Kc value. So the Kc value will decrease. Yeah, then comes this question. It says, how will each of the following affect the yield of P? P happens to be one of our products. And they say write increase, decrease. or remain the same. The first one is increase in pressure. How do you assess that one? Okay, let us derive the equilibrium. If you have x plus y giving you 2z plus p. Okay, if you are going to predict pressure, it is mandatory to count number of moles. On the reactant side, you have how many? 2. On the product side, you have how many? 3. And you have to know that according to Le Chatelier, increase in pressure favors the direction which reduce pressure. And that is from high number of moles to lower number of moles. The direction is reverse. And if reverse is favored, how will it affect P? The answer will be decrease. Okay, next one is increase in temperature. How do you go about that? Okay, the first or the best approach is to have the equilibrium, which is x plus y giving you 2z plus p. Remember, we found enthalpy change as less than 0. Okay, and you need to know that what you have here, which is the enthalpy change, is for the forward. Less than 0 means exothermic, so meaning forward is exo and reverse is endo. And according to Le Chatelier, increase in temperature favors endo. And the endo is reverse. So what will reverse reaction do to our product P? It will decrease. Yeah, then next, increase in X. How will increase in X affect the yield? Okay, we have the equilibrium x plus y giving you 2z plus p. And here we are increasing x. What happens when we do that? Okay, when we do that, we are disrupting the equilibrium. And according to Le Chatelier, that one is not liked. So whatever you are adding will react with y, so y will drop to give you z and p. So what do we notice there? The amount of p is increasing. So the answer is increase. Yeah, then next, addition of inert gas. Okay, so when you look at our equilibrium, which is x plus y giving you 2z plus p, addition of inert gas, in case you have this one as the container, what inert gas does is that it comes and occupies a space out of the container. So when you observe this, what happens? The volume decreases. And when the volume decreases, what happens? The pressure increases. So in other words, addition of inert gases is tantamounting to increasing pressure of the system. The question is, when you increase pressure, what happens? Now remember, to predict pressure, you need to count. This side will have 3, and this side will have 2. Okay? And if that's the case and you're increasing pressure, what does Le Chatelier say about increasing pressure? He says that increasing pressure favors the direction which reduces pressure, and that direction in this case is reverse. It's from high number of moles to lower number of moles. So what do we notice here? Reverse is favored. And if reverse is favored, what happens to P when reverse is favored? It decreases. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yes, we urge you to subscribe, to comment, to like, to share. And we need also to remind you that Physical Sciences Silver Bullet is a YouTube science channel specializing in physical sciences, grade 12, 11, and 10, and natural sciences, grade 8 and 9. We advise you that when you are using our channel, you should not go to video, go to playlist. This is because of the big scope of this channel. If you go to video, you won't be helped because videos are mixed up. So just go to playlist and click the material which belongs to your level. For grade 8 and 9, just go to natural sciences, grade 8 or grade 9. For grade 10 and 11, just go to physical sciences, grade 11 or grade 10 and click the tile. As for the grade 12, each chapter is presented as independent tile. So just go to the chapter of your choice and click. With that, I would like to say thank you. We love you. See you next time. Bye bye.